Today we are working on determinants for 3 by 3 matrices. So determinants, determinants of 3 by 3 matrices. For example, you have matrix 3 by 3 determinant, or I denote it like an A matrix. Here we have denotations. We worked with 1 1, 8 1 2, A 1 3, A 2 1, A 2 2, A 2 3, A 3 1, A 3 3, A 3 2, and A 3 3. Okay, the first one step here, we have to define kind of the sign of the terms of the determinants. By the way, the number of terms here is 3 by 3 number. This is the property of the determinants. And we have here this sign. There is a very great sense of these signs, and it is about permutation and inversion, but I think it's better to use the mnemonic rule. So the very first number here, you can denote like positive coefficients, and then you can to switch the sign or the elements. So if it is plus, it's not if, but it's always plus. We have here minus, plus. Since that, if we have here plus, so we switch it minus, plus, and here we have plus and minus, minus, plus. It's clear. So the first one element A11, it is always plus. The other one, you have to switch the number, the sign. Okay, next one step here, you have to, if you have to pick out any row or any column. For example, I want to pick out the first one row here, and I have to move along this row and take some set of elements here. So I have to take A11 and Y1 and multiply. Now, if I take this A11, I have to exclude the first one row here, and the first one column, and the rest part of the matrix here I have to take as a 2 by 2 matrix. A22, A23, A32, A33. So next one element A12, I have to take this element with this sign minus A21. But now I have to exclude the first row and the second column here, and the rest part of matrix. I have A21, A31, and A23. A33, they goes into the second 2 by 2 matrix. A21, A23, A31, A33. And then last one goes A13. And I have here, I take these elements, last one, and I'd have to cross out the first one row and the second last one column, and the rest part of the matrix forms the last one 2 by 2 matrix here: A21, A22, A31, and A32. Now I'm ready to calculate the determinant of the matrix A, and it is A11 times 2 by 2 matrix. We can't calculate. We have to take the first determinants. We have to take the first two elements with sign plus along the main or principal diagonal or the leading diagonal, and they are A22 times A33 minus A23 times A32 minus A12. Here we have to use the same rule. A21 times A33 minus A23 times A31. And the last one element plus here A13 times A21 times A32 minus A22 times A31. We are ready to calculate. This is the determinant of the matrix A, because if you have some numbers, we can combine them, add, subtract, multiply, and we have some number here. Okay, you can ask me why I put these signs. Because it's your choice. You can take any row, any column here as a basic column. For example, I can calculate determinant of these metrics if I use determinant A. If I use, for example, I want to take as a basic elements the second column here. It's my choice. It means that A1, for example, A12, A22, A32. So I can move along this column. But I have to take this corresponding number. So if I take the first A12, I have to take this number with this minus. So it goes minus A12 times determinant of the matrix. The same approach. I have to cross out this column and this row. And I have A21, A21, A23, A31 here, and A33. Next one, because I'm moving along this column, goes A22, but it goes with this positive sign, plus A22. But I have to exclude this row and this column and this row. So the row and column within which A22 is located, and I have A11, A13, exclude them and take beyond part, element of the beyond part of the rest part of the matrix. A31, A33. Last one goes again with minus. And it goes with A11, A13, A21, and A23. These minuses and pluses, they work only for the first element here. When you construct the rest part of the 2 by 2 matrix, you have to take the elements with their and keep their signs in the basic matrix. And the same trick you can do with if you are moving along the last one or along the last column here. All of these ways give you the same number because we calculate the same determinant. Example. I tried to pick out a matrix with very special numbers to make more clear why I showed you the two approaches to calculate the previous approach to calculate determinants. For example, matrix A is 1, 2, 3, 0, 5, 6, and 0, 4, 7 elements. Let's calculate determinant of the matrix A. Determinant of matrix A is unknown. So we have determinant A equal 1, 2, 3, 0, 5, 6, it is 5, 0, 4, 7. Okay, so the first one step here we have to define pluses and minuses. So plus, minus, plus, minus, plus, plus, minus, minus, plus here. Okay, so we have here equal 1 times 5, 6, 4, 7 minus 2. We replace the first column, the first 0, 0, 6, 7, and plus 3, 0, 5, 0, 5, 0, 4. And we have here 1 times 5 times 7 minus 6 times 4 minus 2, 0 times 7 minus 6 times 0 plus 3, O times 4 minus O times 5. We are very lucky here. We have 1 times 5 times 7, 35 minus 6, 5, 4, 24. O times 0, 0, and the last two terms they give zeros, and we have 35 minus 24, and it is 11. It's a regular matrix, by the way. But we can use the other way. Determinant A equal. We can move along the first column because we have two zeros here, and it means that the last one element, all elements which consist of 0 here, they give 0, and I have here 1 times 5 times 7 minus 6 times 4. Because the first element 0, it means that all of these terms, they are zeros, and I have only one action here. I have 35 minus 24, and it is 11. So here I have 1, 2, 3 lines of calculation, and for this one approach we have just one line for calculation, one term, and we have the answer 11. Okay. But sometimes it's clear that we will won't have always zeros in the given matrices, but we can transform our matrix so that we can eliminate some elements, turn them into zeros, and then try to calculate determinants of the matrices. Let's do it. But for previously we have to define some properties of the determinants.